Alright, we've got our mini spinner going today. This is what our mini spinner looks like. It's a cap from a bottle of hairspray or something. It has a little tiny mirror. On top of it there's some magnets spinning around, and basically all you need to build this thing, one of these waver toys, solar waver toys. You take them apart. I use this type mirror from the 99-cent store. Let me move my finger so you can possibly read what it says there. Blind spot mirror. These things are actually shaped the wrong direction. They're like that. We need a cup type shape. So I take the plastic off. You just cut into the back of it, and pretty soon the black plastic will come apart. And being how this top here looks shiny, that means the coating is on the other side. I flip it over. I take some of this soft steel wool and I rub out all that coating on the back side, which this is spinning on the back side that did have a coating. Alright, to give it the mirrored look, I bought a I forget what it's called, mirror in a can or something from Home Depot that you can spray paint. I spray painted what used to be this side, the top side, which was blank when you initially take it out of here. The coating's on the other side, so I put the coating on this side. Let me see if I can show you here. Get this thing lined up a little bit. This started out as a monkey toy, and it actually didn't even work out in the sunlight. The toy itself, one of these really tiny wires, I don't know if you can see it right here, was already broken. So basically what you have inside this toy, you have a coil here, you have a solar panel, and you have a little circuit board. And the circuit board and the solar panel usually come out real easy. Once in a while you have to be careful with the coil because it could be glued to something. This is glued around the edge here. Luckily it popped out already. Like I say, one of these tiny wires was already broken that went to the circuit board, but I dealt with that. Okay, so this is the coil part. Two wires down here, one of them was already broken, didn't make it all the way to the circuit board. And here you see it disassembled, the solar panel, circuit board, and coil. Now, the two wires, white insulated wires coming off the circuit board, did go to the solar panel. You go ahead and cut the wires up by the solar panel. Get rid of the solar panel. We're going to run it on a different electrical source. You can see the circuit board has a plus and a minus. Some of the boards are nice enough to make the plus wire red and this one black, but this one didn't, so you have to look on the circuit board to see which one is positive and negative. This little tiny solder drop over here is where one of the tiny wires that went to the coil went. This other corner is where the other tiny wire to the coil went. I wasn't going to fight with trying to solder what was left of those tiny wires onto these spots. What I did is I decided to add some wires to the coil to make it easier to work with. So I took the coil, I took one of the wires off here to the side and tried to tin it, which basically means take a soldering iron and drag a drop of solder. Here's just a drop laying out here on the surface. It's not doing anything, but my soldering iron, drag it across there, kind of tin it up a little bit to get ready to solder a little bit bigger wire onto it. Okay, here I tried to tin this one over here a little bit. Okay, here's the little bit bigger wires that I soldered to the tiny wires coming off the coil. Now these solder drops here are not too pretty, but they worked. This is just an extra one laying on the surface. It's not in use. Then I took a small chip of plastic and and glued these wires and the coil onto the plastic. That way the tiny wires are caught up in here, and when these big wires get pulled on, they're not going to pull these tiny wires because they can't go anywhere. So that's how I made it safe to work with, those really extremely tiny wires. And so what I'm basically going to do, I'm going to take the tiny wires, the bigger wires I put on the tiny wires, and solder them here to this point and to this point where the original tiny wires went. And where the solar panel was connected to these white wires before, I'm going to use a USB cord to connect that. So here's some wires I prepared to solder to the circuit board. A real short stripping down here, so I wouldn't have too much wire when I put it on the circuit board. Okay, so these wires, these green wires, are where the original small wired coil went in. I'm going to connect those to the other two green wires that I soldered onto the coil. The two white wires here we'll get to in a minute. Okay, the two white wires are going to have a red and a black wire for the power, so I'll know which is positive and negative as I work with it. Red's positive and black's negative. And I just get that from looking at the circuit board. So the white wire coming off the circuit board that has the plus for positive, I'll use the red wire, I know that's positive. Okay, this is the cheap little USB cable I'm going to use to power this thing. It has a cloth type woven outer insulation, kind of strange, but it works. Here I got rid of some of the cloth insulation, and here inside it had a red wire and a black wire, so I know which one's negative and positive as far as what this USB port is feeding. So to test it, I have the USB power cord, red wire to the red wire, which went to the one with the plus on the circuit board. Black wire to black wire went to the negative on the circuit board. These two wires are going to go out and join up with the other two green wires that are now connected to the coil. Okay. That's what it looks like when I was testing it. Circuit board's actually sitting outside. The connection to the power is sitting outside. And let me go one more forward here. You can see where I use some sticky goo stuff underneath to stick that plastic coil on the back of the mirror. Your coil should be roughly between, somewhere around the edge of the coil should be toward the center or just a little bit back. Somewhere in there is the sweet spot to put the coil. Okay. This end of the USB that had the frayed insulation over here, I use heat shrink to pretty that up, and also it tapers down because I know now I disconnected where I had it tested for connected for testing. I'm going to run this through a hole in the cap. Here's the cap that will hold the mirror, and the USB cord comes through there. And by the way, I put a tiny dab of super glue there to help hold that. This is some of the heat shrink I used in this project. Okay, so here I've got the power coming in, going to the circuit board. I've got the two green wires I added to the coil. They come out and meet these two green wires that I added, that I soldered to the circuit board. And I used heat shrink where they connected in all these spots. Then I basically take the little circuit board, dump it in the cap, the extra wiring, kind of shove it in the cap. The mirror backside will get glued to the top of the cap here. Here's the mirror facing down. While I'm gluing it, I put a little bit of weight on top of it so that I could push the cap right down into the mirror and let the glue dry. So here's what we have basically. One of these little Waver toys has three components you can think of it. A coil, a circuit board, and a solar panel. Of course I clipped the solar panel off and use a USB cable. So if you're able to get the coil out with these tiny wires intact and nothing damaged, you can just take the circuit board and glue it to the coil. I did this on the first one I built. I don't have a film of that. And then you can actually not add power wires. You can just take the USB cable wires to the original 2 wires coming out of the circuit board. And I've done that on my first build, worked okay. But this build didn't come out as good. So, I mean, it works, but it wasn't as easy. I ran into some problems. Let me see here. Also, a coil I wound of 34 gauge wire on a sewing bobbin I tested with this circuit, and it worked fantastic. A couple of size magnets that I used that worked good with this. I'm sorry I've switched back between inches and millimeters, but these are a couple of, one set up here and one set down here that work good with this. Usually a smaller set of magnets, let's stop this a second, works good, but this is what was working on this one, this particular set, and this slightly larger set over here. Let me back one up so I'll get the magnetic field out of the way. See if I can get this thing going again. Yes, this one may need a faster spin to keep it going. There we go, faster spin, it's going now. So let me see if I can get this thing apart real quick to show you what's inside these. And they all look a little bit different. Let's see if I can get this open. I'm into dangerous territory. I didn't put that deeper than I wanted to put it. Okay, let's see what we got inside this one. Okay, good. Everything fell the other way this time around. There's our coil up there. Oh my. I guess I just bumped it off what it was attached to. But you can see it's the same thing. Circuit board. Oh, careful, careful, careful. Don't have my glasses on. My goodness. Wow, it looks like this one's still intact. If it is, then all I would have to do, cut the little solar panel off. I use the white wires for the power in. Glue this circuit board right onto the coil. Glue the coil onto the mirror. You've got your whole device. You got your whole device there. I don't know. I was out of frame, but you would glue the circuit board right onto the one side of the coil, and that way the wires wouldn't have anything to pull them. You glue the coil onto the back of a mirror and cut the wires going to the solar panel up here. Check the circuit board for which one needed to be positive, negative, run a USB in, and you've got it. So there we go. Still running good. And that's how you build these little things.